All right, ladies and gentlemen, we're going to jump into patterns and linear functions. This is section 4.2 in your notes. This is what you grabbed when you came in today. From slide. There we go. Bam. All right. So the activity that we did last week with chemical X, we talked about a linear function. You may have not known it was a linear function or may not have known that. Hopefully you guys saw the pattern. A lot of you guys were noticing some things that were going on with it. So here, number one, it says, in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. And if you notice, we did the same thing last week with chemical X. So we've got one rectangle, and then it shows some numbers around here. 2 rectangles, 3 rectangles, 4 rectangles. And it doesn't really give you any guidance besides anything else on the picture, but we know up here that we're finding the perimeter. Perimeter, remember, is the distance around something. So I'm like the perimeter around my face, because I'm doing that right now. Or the perimeter around these rectangles that are over here. So let's go jump in and do this. So we're going to make a table, step 1. So let's go ahead and do that. So I have my pin. The number of rectangles is X. So we have 1 rectangles, 2 sets of rectangles, 3 sets of rectangles, and 4 sets of rectangles. And so we can go back and look at the perimeter to find it. So in our X column, we have number of rectangles. That's the number of rectangles that are in the picture, 1, 2, 3, 4. And then in our Y column, we're actually going to do the perimeter. So let's do the perimeter of this first one. We have 6, 1, I know 6 is over here, and I know 1 is over here. So if I add all those up, 6 and 6 is 12, 13, 14. So my first perimeter is going to be 14. And if I write that as an ordered pair, that gives me 1, comma, 14. I'm using the mouse, that's why it looks a little weird. So you'd think then the number of rectangles too, the perimeter would be 28. And a lot of people make that mistake, but let's go back and actually count it. So I have 6, 6 on the other side, and then 2 1s on the bottom. So 6 and 6 is 12, 13, 14, 15, 16. So it's actually just 2 more. And so you guys saw what I did yesterday is I added 2 here. Okay, so that tells me that it's going to go up by 2. And then 2, comma, 16. And I moved me out of the way. So we saw that it was plus 2. With the chemical X, we had a times 0. We actually want that too. It's going to be super easy to get an equation if we have times 0. So eventually we're going to see a pattern that we have, and then we can figure out what's going to happen at rectangle 0. There actually can't be any perimeter with rectangle 0, so it doesn't make sense in the problem. However, we'll need it for our actual equation. So let's go back again, count for 3 rectangles. So 6 on the other side, then 3 1s. So 6 and 6 is 12, 13, 14, 15, 16, 17, 18. So we're going up again by 2. And then that gives me 3, comma, 18. Move me out of the way over here. We already know that that's 4. So we have that, and then the next one, if just by guessing, we assume it's going to be 20. Let's go ahead and look. So 6 and 6 over here, and then 1, 2, 3, 4. So 6 and 6 is 12, 13, 14, 15, 16, 17, 18, 19, 20. It is. Sweet. That's exactly what we expected it to be. So now I have plus 2. Oh, I forgot to close parentheses that. Sorry. 4, comma, 20. So now I have 4 points, 4 ordered pairs. I'm going to bring my mic closer. I don't know if you guys were able to hear me quite clearly for the first part. Maybe now you can a little bit better now that I'm bringing it close. Bam, there we go. There's my mic, by the way. Boop. It's called a snowball because it looks like a snowball. There we go. Hopefully it's a little bit better. We're going to follow that pattern back to 0 rectangles. And this doesn't really make sense because we can't have a 0 rectangle that doesn't have a perimeter. But I want to find out when x is 0, because when x is 0, we can find our y-intercept. So when x is 0, actually don't want that over there. Let's move me up here. Let's get an eraser. I don't want it right there. Eraser, pen. All right. So when x is 0, so if I go back, so let's think about like going backwards. So if I subtract off 2 each time. That's what I'm doing. 20 minus 2 is 18. Minus 2 is 16. Minus 2 is 14. Well, if I go back 1 here, that's 0. If I go back 2 here, then that's going to be 12. So my ordered pair for that instance is 0, 12. And we need that for the next part. We're actually done with the table. Everything is finished with the table. We're done. Table's fantastic. We got all of the instances of the pictures covered. Everything is in. We have rectangles. We have our x. We have our x. We have our y. And we have our ordered pair. This is backwards for me, so it's kind of hard to see. Ordered pair. Bam. Right over there. All right. So that's the table. Step 1, part 1. Step 2, 3, and 4. So words, equation, and graph. So the words is what we talked about last time. We can use our table to get our words. So we got to set up the problem. So I'm going to use my finger, so it's going to look a little bit crazy. So the problem shows an increase in perimeter and rectangles. All right, so that's kind of the introduction at one rectangle. But wait a second, didn't we do 0? Well, we did 0 because there was 0 in our old problem when we were talking about chemical X. For this problem, there isn't a 0 rectangle. We need it for our equation, but that's it. So at one rectangle, the perimeter, Mr. Brummond. Hey, look, there I am. Hi, me. Eraser. Bam. Didn't realize I wrote that much. There we go. The perimeter is 12 units. No, 14 units. Notice I'm adding a label at the end. It doesn't tell me what my unit is, so it's units. At one rectangle, the perimeter is 14 units. At 2 rectangles, comma, the perimeter. Did it again, the pre-meter, man. Let's try that again, Mr. Brummond. I believe in myself. You can do it, me. The perimeter is 16 units. I'm writing way too big. I'm going to have to erase this when I get finished so I can do my other stuff on here. The perimeter is 16 units. Finally, that's kind of a conclusion. I don't want to use the word finally. Sorry, I'm doing a lot of erasing. This is my rough draft. Good thing you guys are writing in pencil. If you're not, start. This pattern continues. And then what do we notice about the pattern? Well, for each rectangle we have sorry, it's not reading my finger. That's why it looks crazy. And it's doing that. For each rectangle we add 2 to the perimeter. Did it again, man. To the perimeter. It's really hard to write with your finger. Perimeter. Man. Alright, now I need a conclusion. Finally, we can follow this pattern indefinitely. That means forever. All right. So if you need to finish writing that, go ahead and pause the video now. That way we can get all down, and then I'll give you a second to jump in, and then the next thing we'll do is equation. So let's go ahead and do that. So pause it if you need to. Here we go. So now, boop, all of our hard work gone, but it's still on your paper. The next thing we need is the equation, and the equation is same thing that we saw last time. So we're looking at our rate of change. So the rate of change, y equals our rate of change times x. Our rate of change, well, how much are we going up by each time? Well, we're going up by 2. And then it's the constant number that's added. And if I go back and I look at my table, the constant number that I add each time in this case isn't 14 because I have to go back to where 0 is. So that's where the 0 comes into play. So that's why this part right here was super important. So the number I'm adding each time is a set of 2's, but I'm even adding a set of 2 here, and I'm adding it to that 12. So it's actually y equals 2x plus 12. So this is a note. Note. Always find when x is 0. Find. Why am I writing with the mouse? Find when, looks a little better, when x is 0. When x is 0, then you find out what that last number is. So there's your equation. And then finally, we get the graph. My favorite part. I love graphing. I need a title for my graph. My title is going to be Perimeter of Rectangles. Perimeter of Rectangles. Bam. On my x-axis, I have number of rectangles. So number of rectangles. And then my y-axis is going to be perimeter. My perimeter depends on my number of rectangles. Perimeter. All right. So let's go ahead and put that in. So I have 1, 2, 3, 4. I'm going to start with 0 as well. Now, got to be really careful. I'm going to go up by 2's, but I'm going to skip one because of space on my slide. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So you have to be really careful because on that table we put at the very bottom, we put it very low, we put 0, 12. However, you can't have perimeter with no rectangles, so we actually don't label it on our graph. Be very mindful of that. The next thing we had was at 114, so that existed. So at 114. The next thing was 216, 318, and then 420. So all of those ordered points. And your math teacher last year may have made you put ordered pairs by those points. That's perfectly fine. I don't have space because my fingers are huge and my screen is small. However, I do want to point out you do not connect those. And the reason that you don't connect those is because I want you to ask if you can have perimeter with half a rectangle. But Mr. Brummond, isn't half a rectangle? Isn't that a thing? Well, it's not. You need a rectangle, 2 rectangles, 3 rectangles. This is called a discrete function. Discrete function. A discrete function is one that has special values here, 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 and here. So you can't say, okay, I'm going to have this and a half. Doesn't work for discrete. Basically, if you think you can't have fractions or decimals of it, then it's going to be discrete. If you can have decimals and fractions, then it's going to be continuous. So the number of students in my classroom right now is discrete. That's a discrete value. I don't have half students, I don't have 3/4 students, but Mr. Brummond, what if I cut my, don't cut your legs off, like seriously, like that's just really messy and you don't want to do that, so please don't. So we have now the equation and the graph. If you need more time to copy it down, please pause the video now, otherwise we're going to jump on to the next part. So here we just talked about a function. A function is a relationship that pairs each input value with exactly one output value. So think about this. A function is a real world scenario. And that's what I want you to put next to it. Real world scenario. If it's not a function, than it can happen in real life. For example, I can't be in two places at the same time. That's something we're going to show, you're going to see again, but I can't be in two places at the same time. A linear function is a function. You got that totally because you can read. Also, stay hydrated. So what we just saw was a linear function. But Mr. Brummond, there wasn't a line. Well, if we connected it, it would have been a line. Also, when we did our chemical X, that was a linear function. So everything that we're doing in this particular section is linear function. Why? Because it's a line. Linear function. Line. There's also something cool called the vertical line test. The vertical line test is when you take a piece of paper straight up and down, and then you move it across. So if you move it across from left to right, that just did right to left because I'm backwards. If you do it from left to right, just like this, and it only passes through a point on the graph at one time, it can pass through multiple points that are on the graph, but it only passes through one point at any given time, then it's a vertical line, then it's a function, and then it fits our real world scenario. If it passes through more than one time, then you have things like being in two places at once, which you can't do. So this is another example of representing a linear function. If you guys see that you have examples on your homework for number 1, then number 2 and 3 are this right here. So representing a linear function, I'm going to just kind of casually get into this because at this point, this is almost an actual like problem you can do. And so I'm just going to start this off and then you're actually going to finish this problem. And then at the end, I will show you the answers. So we're going to represent a linear function. The table shows the relationship between the number of photos X you take and the amount of memory Y in megabytes left on your camera's memory chip. This is a crazy problem. Think about on your phone. You taking a bunch of pictures on your phone. Is this relationship a linear function? Describe the relationship using words, an equation, and a graph. So it actually says, look for a pattern, words, and equation. So we already have it here. We already have what's going on. So let's go ahead and write some of the things we did. So first we need to find when X is 0. Sweet, it gave it to us. So when X is 0, Y is 512. How do I get from 512 to 509? Yeah, no, go ahead and tell me. How do I get from 512 to 509? Exactly it. Yeah, I subtract 3 every time. Excellent. Good job. Especially you in the back. Minus 3 each time. So minus 3, minus 3, minus 3. So that's my pattern. So that's my rate of change. So for my equation, it's y equals my rate of change. So that's negative 3 each time. X, and then plus, because this is a positive, 512. And that kind of makes sense. For each picture we take, it decreases from that 512 until you run out of room on your phone, and then you can't take any more photos. Unless you upgrade to a new phone. It came in. I'm pretty excited. Totally didn't check my phone in class. Sorry. So we did the equation. Now we need to do words. So what I'm going to do is I'm going to give you a chance to go ahead and do the words on your own. And what I'm going to do to make sure I'm accountable is I'm going to check your words when I come back tomorrow. And then we're going to then do the graph together in class as our warm-up, our problem of the day. But let's do it in here too. I have something else I want to do for problem of the day. I lied. Sorry, I'm a terrible liar. So words and the graph will do together. Words will be at your table. You guys will come up with your paragraph together with your table. Graph will do together. I'm trying to fit this video under 20 minutes because I want you to have some time to work on your homework, also assuming times for stopping. If you need to go back and watch the video, please go ahead and do so. Good luck. You now have enough to actually finish your homework that you just got today. Combine that with the homework that we did yesterday. Sorry, last Friday. You should then use the rest of the class time to work on both of those homework assignments. I'm going to make that homework assignment due... See, today is Monday. I'm going to make it due Thursday because I'm going to get back on Tuesday. So we'll get that back on Thursday. We have a quiz coming up soon, so just kind of put that on your radar for things that we have doing. And I hope you guys have a wonderful day. I will see you later. Bye.